Liam, hi. Listen, I came across the term fusion in neural networks. Is that a new model?
Hey, Jess. Not exactly. Fusion isn't a model, it's a technique, kind of a trick that helps a neural network combine different types of information.
Different. Like what, for example?
Well, think about it. We perceive the world not only with our eyes, right? We hear, remember, feel. Similarly, a neural network can analyze an image and text at the same time, or say, images from different angles. That's all fusion. This capability allows the network to see more broadly and make more accurate conclusions because it's analyzing multiple sources of data at once, not just one.
And how does that work technically? Are there different types or levels of fusion?
Yes, there are three main types. The first is early fusion. That's when data is combined right at the input. For example, if you have an image and thermal data, you just stitch them together and feed them into the network. All the data is merged at the entry point, like RGB image plus thermal. Just combine them right away and send them in.
But what if the data is too different?
That's where intermediate fusion comes in. Each type of data is processed separately by its own part of the network, and then the features are combined somewhere in the middle. It's more flexible than early fusion. Want an example? The clip model. It analyzes an image and text through separate eyes, and then merges their meaning.
And the third method?
Late fusion. Here, each type of data goes through its own complete neural network. So each data source is fully processed independently, and only then are the results or conclusions combined. This is useful when you already have ready-made models for specific data types.
Where is this used in real life?
Oh, pretty much everywhere. In medicine, combining MRI and CT scans. In self-driving cars, cameras, lidars, and radars. In satellite systems, images in different spectrums. And of course, in multimodal networks like CLIP, which link text and images.
Can you explain how neural networks use fusion in medicine? Like, for diagnosing brain tumors?
Oh, that's a great example. Let's imagine a scenario. A patient comes in and the doctor needs to determine if they have a tumor, where it is, and how dangerous it might be. For that, they use multiple types of scans. First, MRI. It shows soft tissues really well. You can clearly see the tumor itself. Then, CT. It shows bones and the skull shape. That can be crucial if the tumor is near bone tissue. Sometimes there's also PET. It shows how active the cells are, or in simple terms, how aggressive the tumor might be.
So each scan tells a different part of the story?
Exactly. None of them on their own gives the full picture. An MRI might show a spot, but it's unclear. Is it really malignant or just swelling? PET says, here the cells are metabolically hyperactive. CT shows whether the bone structure is being damaged. The doctor mentally combines all this information to make a decision.
And the neural network does the same?
Yes, only it doesn't have a consciousness to see and compare data like a human doctor does. So we build an architecture that imitates that process. For example, we create three separate branches, one for MRI, one for CT, one for PET. Each is like a mini neural network that learns to understand its own modality. Then comes the magic. We take what each branch has learned, these are called features, and combine them. That's fusion. And we don't do it right away, but at some intermediate point when each branch has already seen something meaningful. This is called intermediate fusion.
And what happens next?
After merging, we get something like a team report. As if three doctors discussed the case and formed a joint conclusion. This combined information is then passed to a classifier. It says, yes, there's a tumor, it's malignant, developing aggressively, or no, everything is clear. It might even draw where exactly the tumor is. That's called segmentation.
Wait, how does a neural network learn to make such diagnoses? It needs to have the correct answers to compare with, right?
Great question. Of course, that requires labeled data. Before the network is used in a medical setting, it has to be specially trained. Doctors manually outline tumor locations on patient scans. They indicate diagnoses, types, stages, etc. This data is fed into the model during training.
So the neural network learns from real patient data, analyzes where it made mistakes, and corrects itself?
Exactly. We give it several scans and the correct answer. It makes a guess, and we check, was it right or not? If not, we show where it went wrong, and it slightly adjusts its internal weights. And this happens hundreds of thousands of times until it learns to interpret MRI and CT scans thoroughly and accurately.
That sounds like an insanely complex puzzle.
Yeah, and that's what's awesome about it. The problem is, such data is rare. It's hard to collect. Scans have to be perfectly aligned. MRI and CT for the same patient must match up spatially. Plus, every patient is different. Some have huge tumors, others tiny ones. Some have rare cases. The neural network has to learn to deal with all that variability.
And despite that, the neural network still works successfully?
Yes, a well-trained model can spot a tumor a human doctor might miss, especially if it's small or in a tricky spot. Most importantly, the neural network doesn't get tired, distracted, or stressed. Essentially, we're building the perfect assistant for a doctor, automated, fast, and accurate.
So fusion helps a neural network work in a more comprehensive way, considering all kinds of factors. Almost like a human?
Exactly. It's not just adding more data to what you already have. It's a way of applying a broader, integrated approach. Without fusion, a model is blind to other sources of information. With fusion, it's like it gains depth perception. And that's critical, especially when human lives are at stake.
Thanks, Liam. Today I realized the enormous potential opening up for professionals in many fields. How powerful these new AI technologies are becoming. It's like humanity is entering a new era of technological progress.
Let's talk more about that next time.